Hello everyone. So today we're going to take a look at the second section of our finance unit. This one's titled Investments Using Compound Interest. So clearly we're going to take everything we've learned for compound interest and sort of build on it. So what we're going to do for this section that's new is we're going to take a look at compound interest that does not compound every year or annually. So if you remember, compound interest or the compound period is the period where we take the interest that's accumulated in an investment or a loan and then we add it to the principal for the next year. So now we have a larger principal that we're going to get slightly more interest on as we move forward. So last section was exclusively compounding once a year or annually. That's a really common compounding period. Other common ones include quarterly, so that's 4 times a year, or semi-annually, so that's twice a year, which would be every 6 months or so. Okay, so we're gonna take a look at it first using the formula we're familiar with already, which is this guy here. So we're gonna need to use a slightly different formula to calculate problems that don't have annually compounding interest, but we can use the same one. We just have to use a few different values for what n and for what I now represent. So the I value was our interest rate from before. It's still going to be our interest rate, but this time it's going to be our interest rate per compounding period. Okay, and the n value, instead of having that value be the number of years, this one now is going to be the number of compounding periods in a year. Or sorry, just the number of compounding periods, not in a year. Compounding periods total. Okay, so what does that mean? So let's talk about our I value. So because it's not always going to be yearly, the I value doesn't necessarily refer to the annual interest rate anymore. Although it will if we're compounding annually. If we're compounding annually, then you know I is just the interest rate. Okay? But if it's not compounded annually, this is what you have to do. You take the annual interest rate, of course, as a decimal, and all you have to do is divide it by the number of compounding periods in a year. You're evenly dividing that interest amongst the compounding periods. Okay, so here I have a nice little chart. You might want to pause the video here and just have this up for you if you're working through the problems. So this just tells you how many compounding periods you'll have in a year, depending on how the interest is compounded. Okay, so at the bottom we have our annually compounding interest. Of course, if that happens, that just means the interest is being compounded once a year. So the number of compounding periods is 1. If it's semi-annually, that's every half year, every 6 months, so we compound it twice in a year. If it's quarterly, it's 4. If you compound it monthly, of course, there's 12 months in a year, so it's going to be 12 times that the interest is compounded. Weekly is 52, and daily would be 365. Okay. And then on the topic of the n value, we're no longer talking about the number of years, unless of course it is compounded annually. If it's compounded annually, then n is just the number of years. But if it's not compounded annually, we need to take the number of years and we multiply it by the number of compounding periods in that year. Okay? And that'll give us the total amount of compounding periods. So it makes sense, right? If we had a 2-year investment and it was being compounded semi-annually, so that means 2 times a year, that means we would compound it twice in the first year and twice in the second year. So we would have 2 times 2, because there's 2 years and there's 2 compounding periods in a year if it's being compounded semi-annually. So that'd be 4 total compounding periods. Twice in the first year, twice in the second year, total of 4. Okay? So let's do a few examples here. So the first one, if the annual interest is 6% per annum, which means per year, state the interest rate per compounding period and the total number of compounding periods in each case. So this is compounded semi-annually for 5 years. So semi-annually means twice a year, which means we would have 2 compounding periods every year. Okay, so let's take a look. So let's do our I value. So if we go back up, oops, too far. Our I value is our annual interest rate as a decimal divided by the number of compounding periods in that year. All right, so our annual interest rate was 6%. So as a decimal, it's going to be 0.06. And the number of compounding periods in the year is 2, because it's twice a year, because it's being compounded semi-annually. Right? So that would give us 0.03. So essentially what we're saying is for each compounding period, the interest is 3%. So we have 3% in the first half, 3% in the second half. So in the whole year, we get that 6%. Okay? And we can do our n value, total number of compounding periods. So we can go take a look at that. So that's the number of years. So let's take a look. This one is for 5 years. So it's going to be 5 times number of compounding periods in that year. Well, again, this interest is being compounded twice a year, semi-annually. So for 5 years, there's 2 compounding periods every year. So there's going to be a total of 10 compounding periods over the course of that entire investment. Okay? So if we wanted to do a calculation for the final amount of the investment, we would use an I value of 0.03 and an n value of 10. Of course, we're missing the other information to finish this question, but that doesn't matter. All right, we can do the other one. So this one is compounded monthly. So how many times a year is it going to be compounded if it's monthly? Well, 12 months in a year. So this is going to be 12 times a year. Right? For 6 years. So our I value, still 6% per year. So it's going to be 0.06 as a decimal. But now it's being compounded 12 times. Right? So if you do the math on that, 0.06 divided by 12 is going to give you an interest rate of 0.5%, or 0.005. Okay. And then our n value, total number of compounding periods. Again, this is going to be sitting in the account for 6 years. And we're going to multiply it by 12 because it's being compounded every month. Right? So we get an answer of 72 for that one. Total compounding periods. right? So if we wanted to calculate the final interest for this one, if we had the other information, we would be using an I value of 0.005 and an N value of 72. So hopefully that's pretty straightforward. It's just two simple formulas, I guess, to calculate this one. We can do the next question here. We're actually going to do a few calculations for this one. So let's take a look. $3,000 is invested for 5 years at an annual interest rate of 7%. Complete the table below to calculate the final value of the investment if the interest is compounded according to the period of time given in the table. So we have 4 different compounding periods for this question: annually, semi-annually, quarterly, and monthly. So the first one, annually, this is a question you could have seen from the last section where we were dealing strictly with annually compounding periods. But we can do this anyway. So if we're compounding annually, the number of compounding periods in a year is once a year. The total number of compounding periods, if we're investing for 5 years, and it's 1 time a year, that's 5 times 1. So obviously that's going to be 5. The interest per the compounding period, so we got 7% here, so that's 0.07, but we're only compounding once in a year. So that's just 7%, right? Okay, and our formula, A equals 1 plus I to the power of n, and that's going to be times our p-value on the outside, right? So I guess I should kind of move that over just to stay constant there. So for this one, our p-value, well, the p-value is always going to be 3,000 for this question. Might run out of space here. 1 plus 0.07 raised to the power of 5. And I guess I should go and grab my calculator here. So if we do that, so 1 plus 0.07 raised to the power of 5 times 3,000. So that gives us a value of $4,207 and about 66 cents for that one. So now let's do something that's new. Let's deal with the things we've just learned in this section. So semi-annually, so that's twice a year. Again, if you're unsure, you can come and take a look at this table I made for you. So semi-annually is 2. Okay. So the number of compounding periods in this case, or sorry, the total number of compounding periods, that's our n value. So again, it's 5 years of investment, but we have to multiply it by the compounding periods every year. So it's 2 every year. So this time we're going to have 10 total compounding periods. Okay, so that's our n value. And our I value here, again, we're going to start with 0.07, but we're going to divide it by 2. Right? Because we have to divide it by the total number of compounding periods. So now this one, is the power of 10. Okay, so what do you think is going to give us a higher amount? Well, let's see. So we get 1.035, and that's going to be raised to the power of 10, and then we multiply that by 3,000. So when we do that, we get an answer of $4,231.80. So we get slightly more money if we compound more often. Let's see if that pattern continues for quarterly and for monthly as well. So if we're compounding quarterly, that's 4 times a year. So our total number of compounding periods, again, 5-year total investment times 4 compounding periods every year. So that's going to be 20 compounding periods this time around. All right. So this one is going to be slightly longer. So it's going to be 0.0175 for our interest rate per compounding period. So our interest per compounding period is going to get smaller and smaller and smaller as our compounding periods go up and up and up, because we're going to be dividing it by a larger number every time. All right, so our p-value, again, 3,000. Try to save some space here. So it's going to be 1 plus 0.0175. And this time our number of compounding periods is 20. So I'll grab my calculator here. So that's going to be 1.0175 in the brackets. Got to raise that to the power of 20. And we multiply that by our principal, which is 3,000. And that gives us a final value of the investment of $4,244.33. So again, the more often we compound, the more money we'll get out of the investment. Okay, and then finally, we'll deal with monthly. So that's 12 compounding periods every year, because there's 12 months in a year. So we're going to take 5 times 12 is going to give us 60. And now we got to take our 7% divided by 12. So what does that give us? 0.07 divided by 12 gives us a really long number, 0.0058 approximately. So it's going to be 3,000. 1 plus 0.0058 to the power of 60. All right, so that's going to be 1.0058 in the brackets, raised to the power of 60, and then times 3,000. So this one's going to give us $4,244.43. So you get 10 cents more. Big deal, right? Okay. So I hope that makes sense. Really, the only thing we're changing here is the value of the I value and the value of the N value according to the number of compounding periods we get. Other than that, we're still using our same old compound interest formula. Okay? So I think that's all I want to do for this week. Kind of just get you guys used to working with the differing number of compounding periods. So what I want us to do, our assignment for this one is going to start on page 515. And I just want you to do the first 2 questions. Okay? After that, we're going to be moving into the TVM solver again for most of these questions that essentially does this this formula for us. But I do want to take some time before we move into that for you guys to get used to actually using this formula by hand. Okay? So go ahead, get started on that. Like I said, you might want to have this in front of you for the first few questions. So if you want, you can pause the video and use this as sort of your cheat sheet for the first two questions. All right, so stay safe out there, guys. I hope everybody's doing okay, and we'll see you next time.